Hello, I'm Daniel Himes, and welcome to an intro to BatFish. So what is BatFish? BatFish is a network simulation program. So we are feeding it in a bunch of router configs, and it is running through those configs, seeing how they interact, and uh, figuring out what's going on. So BatFish is a container in this case. Um, And the PyBatFish that we'll be hitting with Python is just accessing that container um, and running off that. BatFish only does layer 3 connections. Don't expect it to be finding layer 2 issues for you. And it is really, really powerful. I've been messing with it for a few days and I haven't even touched on a lot of the stuff it does. I strongly suggest looking into it. It is really powerful and useful. Well, let's take a look at the Docker end of this. So, one of the really nice things about Docker is it doesn't take a whole lot of knowledge to actually get started with it. So, all I'm doing is taking a command I found in the documentation from the BatFish page, pasting it into my Docker VM, and having my Docker VM spin up BatFish. Um, really quite easy. And with that, the Docker image for BatFish is now running on this VM. Let's take a look at the code. So let's take a look at actual working code. So what we're doing in this section is we are connecting over to the Docker host that is running BatFish. We are saying that we are going to be working with the devices in this path, which is snapshots, lab, and under here are the IP tables, hosts, and configs. We're just going to be working with configs, and those are just the show runs out of those devices. So we are saying we are working with the lab snapshot, and it is expecting this kind of format. Snapshots, the set of stuff you're working with, configs, hosts, IP tables. You don't have to have these, but they're there if you decide to use them in the future. Then we are uploading them over to the server, override if needed, and then we are basically loading in those configs and saying that's what we're wanting to work with. If you have already uploaded those, you do not need to upload them again, assuming your container still has the data, but it will save it. So if I were to run this code a bunch more times, I could just comment out that line and not need it. So let's look at the next step. So what we're doing here is you notice that BatFish failed to parse a few lines of the config. That is 100% expected because these are simulations and not VMs. It doesn't know what every line of code you're working with is, but it is important to go through and actually check to see what your warnings are and make sure that there are no lines in here that you care about. So for me, I would very much care about the fact that it doesn't know what to do with EIGRP stubs. So let's take a look at the next step. And I threw in a few pieces of code for you just to spark your imagination and show some of the powerful but really easy things you can do. So here we are going through and finding duplicate IP addresses. My lab is not well made, so there are a bunch of duplicate IPs. Oop, and I hit enter too many times there. So this one is just running through my BGP neighbors, and you can see here this one is probably going to have an issue. R3's trying to pair with 10.0.0.12. There's some issues there I need to look at. And that is just session compatibility. Next, we're going to take a look at tracing the path through the network. So what we are doing here is we are testing the IP flow. So I am running a test from 172.16.1.1 to 172.19.0.12, and I am starting at the office switch device. So you can see here that worked. It started at office switch, went to R1, and then to R5. For our next test, we are going out to 1.1.1.1. Office switch just has a default gateway. It knows all the routes in the routing table of office switch, so it knows that it just went off following the default gateway, which exits the network. So what we're doing here is we are testing flows with ports. This is really helpful for testing your firewalls and ACLs. So the first one is going through same office switch over to R5, and it is doing that with Telnet, port 23. So you can see here, it went from office switch to R1 to R5, and it was denied in, but with this output we've been using, we don't really know anything about why. So, some of the other output options are this one, which is the Panda frames, the Panda data frames. So you can see more data. So you can see the IP it started from, where it's going, source port, destination port, protocol, etc. And you can follow through with each step, and you can see here the last step is it was received on gig 0/0, and it was denied by the access list kill stuff coming in. And if we bring up R5 show IP access list kill stuff, you can see that it would in fact deny that packet. However, since this is a simulation and not a actually creating the packet and sending it through, there's no hits on this ACL line. And then another output is this one. This one's probably the best one, and it also takes the most code to make this one. So we start at office switch. We are forwarded out that interface because it has the EIGRP network for 172.19.0.0, going to that next hop, which takes us to R1. Once again, sends it out, and R5 receives it on gig 0/0, and it is denied due to the kill stuff. But once again, this doesn't have all the information you might want because you don't have the source, destination, protocol, or port. So getting output can be difficult. I would suggest just playing around with it and just to show you what a working one looks like. we are going to hit basically that same path, only with SSH, port 22. And you can see that it was accepted. Same 3 outputs, all of which show that it works. And that is it for the demo. I strongly suggest you to look into this. There is so much here that I have not had a chance to go over. Testing firewalls, testing for devices going down, pretty much everything that you would want to test that's layer 3 is here. At the very least, take a look at the docs, see what's there, and decide for yourself if it's something that's worthwhile. I really think it is. I hope this has encouraged you to take a look. Thank you. Bye.